Cool. So my name's Steve Smith. I'm from Atlassian. That is not particularly important, although I will touch on some of our stuff towards the end. This is really about our internal journey towards continuous deployment, and really about, this isn't a theory. This is practice. This is how did we get a billion-dollar order system into the state where we could deploy it, and how do we actually do that at the nuts and bolts low level. So my original background is I was Atlassian, I think it's over 9 years now. I was the original SysAdmin in the company. I was then moved into the internal systems team, which built the ordering system. And I now work out of Europe, working on developer advocacy, which is partly development, partly doing cool stuff like this, so eating big lunches and getting free beer in the afternoons. So the background to this is, I talk about this as a billion-dollar ordering system. Now, that's largely just a hook to get you in here, and it seems to work pretty well. We will get to $1 billion. It's not what you think it is. Well, it's not as nice as having $1 billion. Anyway, so this is the Atlassian ordering system. This is how, if you've ever bought Jira, Confluence, any of our tools, this is what you've probably interacted with. I am genuinely sorry. I built a lot of this, and a lot of it is kind of clunky and a bit slow. There's a reason it's slow, which is that it has $1 billion passed through it. Now, the background to this is we built our own ordering system. This is one of those things they say for historical reasons, which is really a code phrase for it seemed like a good idea at the time, and now we're kind of stuck with it. The ordering system was built because nothing really matched our business model at the time. Atlassian at the time was quite a unique business model. We built our own ordering system, didn't take very long, and it kind of snowballed from there to now it's like one of the most critical systems in the company, and it's got a little bit out of control. But it does actually work surprisingly well. This is what $1 billion looks like, which is a surprisingly underwhelming when you go and Google for this on the internet. I'd like to have it, but it's not quite the bank vault I expected it was going to be. So $1 billion, when I talk about this, is not $1 billion in Atlassian's bank account. $1 billion pass through it, but some of that is tax, some of it is refunds, some of it evaluations get paid back, all sorts of things go backwards and forwards. But it doesn't matter. Money coming in and money going out are just as important, particularly when you've got regulatory requirements and they expect you to make all of that add up at the end of the day. So the $1 billion order system is how much passed through that system. And I was just discovered that by accident because I was triaging some problem with the system and did a little sum on the table and realized we'd basically just crossed $1 billion. That's about a year and a half ago now, so we're actually well beyond that now. Doesn't mean Atlassian has $1 billion in the bank account or anything like that. It's just a little indicator of how critical this system has become. So, because at this point, a failure of our system is a failure of the business. Downtime for this is now critical. Downtime for this means Scott and Mike, the founders, come and breathe down my neck personally. Or it did. I got out of that team, and now I eat big lunches, which is quite nice. So this is a story of how we tried to make this a little bit more robust, but also and use continuous delivery to do that, continuous deployment. Because a system like that becomes less than agile, becomes somewhat fragile, becomes somewhat, like that tree. It's old, it's cool, but it's also, it works, but it's also, a nest of issues. And a business is growing, Atlassian is growing and wants to continue to grow. Needs to be agile and needs to be able to adapt to changing market conditions, new competitors, new products entering our teams, new products entering other companies' teams that we need to react to. And we need to be agile. We need to be able to change pricing. We need to be able to change products quite quickly and release them very quickly. But at this point, the system becomes somewhat monolithic and was very hard to release. When we started the team, it was 2 people developing this. It's now something like 40 or 60 people on that team. And so the rate of development increased, but that was causing more problems to be introduced as we grew. So one of the things we want to do is break it into smaller services. We wanted to add new pricing models, etc. But we were doing a release once a week, which means that each release was getting more and more changes into it, which meant the chances of any given release causing breakages was quite high. So the decision was made that we would go towards a continuous model. Now, we say continuous deployment, and I'll cover what that really means, but really it's about getting changes out there much faster, but more importantly, in smaller chunks. The smaller chunks you get out there, the more control you have over a given breakage, the more easy it is to identify. And I'll talk about some of the benefits of this model in a bit when I define it and talk about some of the stakeholders and what's going on. This is clearly going to be a hard problem. We're taking a monolithic or near monolithic system that's been built over about 8 years and turning it into something that's going to be continuously deployed and deployed multiple times a day. And it was going to be hard. But just because something's hard doesn't mean you shouldn't do it. In fact, if it's hard, you should do it more often, which is one of the ideas behind continuous deployment and continuous integration and really continuous everything and Agile itself. So we took it on. I was given the job of doing this because I was a SysAdmin and a developer, so I was just like, Steve, you must know about this stuff. There you go. Shit. And so we took that on. Me and we paired with one of the SysAdmin team, and we basically decided, worked out how to bash this out. And then as we came on, we had to pull in more and more people to get this done. But that's the sort of the meta picture. We'll drill more down into some of the ideas in there as I go along. But let's start at the beginning. And let's start with an idea of what is continuous anything. What's continuous delivery? It's continuous deployment. So my uncle is a consultant to some of the top London restaurants, and I asked him, how often do you guys deliver? Out of curiosity around this, how many meals do you do? How many covers do they call it? Someone sitting at a place service and getting fed food. How many covers? So a moderately busy restaurant will do 150 to 200 covers a day, and we're pretty smug that we're delivering like maybe twice a day. So this is actually how the world works. Most places continuously deliver. Most places work in just in time. All of these chefs are there cooperating, shouting at each other. The waiters are shouting at the maitre d', is shouting at the waiters, the chefs are shouting at the maitre d'. But they are communicating, they're getting the job done, and they are doing it in a way that is transparent to the people out on the floor who are just eating this food. So this is the norm, and we think we're pretty clever. So there's nothing special about what we're doing in many ways. We just need to adjust our expectations and the way that we work. So let's review a little bit about what we're talking about when we're talking about continuous deployment or continuous everything. As a quick recap, because they are important, because when you sort of look at them together, all the ideas behind it together, a pattern starts to emerge. So in the beginning, there was continuous integration. Well, before that, there was extreme programming. Extreme programming did something that at the time was pretty radical, which was to say, let's build the software every day. This was 10 years, 15 years ago. This wasn't that far ago. People literally worked for 9 months and then did a build at the end and realized none of it compiled or worked together and spent the next 3 months trying to get the thing into a state where you could actually, release it. The idea that you would build the software every day, and this is before we had test-driven development, or even the idea of testing was a fairly radical idea. This is around the early JUnit days. But the idea that you actually do this continuously was a new idea. Of course, nowadays we're not talking about once a day. Ideally, we're talking about we will do a build on and a test on every commit, and we'll also do a build and test on every commit on every branch that is active currently. And when I say test, I'm talking the full release suite. This can take like up to an hour to run. We parallelize it quite a lot. We've torn that down quite a lot by chucking a lot more hardware and actually AWS instances at the problem. But we always build everything. We always test everything. Because if there's a problem being introduced into the system, we want to find out about it as soon as possible before we actually turn it into a release. And I'll show you one of the ways we do that in a little bit as well. So from there, you've got continuous delivery. Continuous delivery is just an incremental change in front, but beyond that, which is to say that if you're running all these tests all the time and you start to trust your test and you have a commitment to never turn the system into a state where it can't be released, then this is a goal in itself. It doesn't mean actually doing delivery all the time. What it means is we're going to keep our tree in the state that is not broken. That at any point, if somebody went, release now, you'd go, okay, we can do that. It's passing the test. If it's passing the test, then we have got a high degree of confidence that it is ready to go out. So say, it doesn't mean actually doing so, but it's commitment to never breaking the systems. Again, this is actually fairly new idea. It's been quite hard to do up until recently when you bring in DVCSs or modern version control systems where you can have much more isolation between streams of work. And again, I'll show you a bit about how we do this and how we use the development model. But this is really just about saying you're never going to put your main release branch into a state where it's broken. You're never going to have a half-built feature. You're going to only merge into that main branch what is ready to go out. So from there, obviously, the next step is, well, if we can do that, we theoretically could do a release at any point. Why don't we? Now, how often that release occurs and how bigger changes are in those releases is entirely up to your organization and what your goals are. But our ultimate goal is, I'm not sure we're entirely there yet, is to be every release, every unique feature that gets merged results in a release. It's a very powerful idea. It sounds pretty extreme, but it's actually a massive improvement over the normal way of doing things because it gives you much more fine-grained control over what is going out. It also gives you a much better debugging capabilities, but I'll touch on that in a bit. But the theme that runs through all of these is about quality. It's a commitment to having testing, and in particular, it's a commitment to having automated testing. If you can basically press a button and then go, I have a high degree of confidence that what is going to come out of this process will be not broken, will be relatively feature complete, it'll be something that I'm not going to be ashamed to throw out there, you're pretty much ready to go. So this is about quality at its core. There's also the question, and a very reasonable question, of why bother at all? Every organization has their own goals and requirements and business drivers and all the rest. So there's going to be different reasons. I can just give you ours that were clear to us. And it's important to have a clear idea of why you're doing this. Luckily, that's not too hard to do because you'll find people push back, and I'll talk about that as well. But the main reason for us, we wanted to release features, not dumps. What was happening was once a week, we were dumping out whatever was ready to go at that point. Now, that meant you could be a very small bunch of changes, a little schema change, a little optimization, or it could be a massive feature. A whole bunch of things went out. Whole streams of work, pricing models, new products, new emailing system, whatever, could all go out. And we had very little control over that because we only had a single window to do it, which was Monday. Well, this is in Australia, so that was actually our only time to have real downtime. The other reason was automation. If something is hard to do, you should probably automate it. And particularly, anything that's repetitive to do should not be done by humans. Humans get worse as things become more repetitive. They tend to make more mistakes, whereas machines tend to get better at it. The more information you have, the more you can feed back little bugs and problems back into your scripts. The scripts become more and more robust. There's also another reason for automation, which is to remove bottlenecks. We want to release more often, but we also had a bottleneck in the form of humans. By removing humans from the equation, we would be able to release when we wanted to, rather than when we could get the sysadmin's time or the ops time or QA's time, whatever. The more things that are automated, and we can get everything automated, then we don't need to rely on humans being part of the loop most of the time. We don't need to get people's time. Which brings us to, when we're talking about people, which is very important, is the stakeholders. Now, you may know why you want to do continuous deployment, but a lot of people are going to want to push back, and they should do, because this isn't something you do trivially. Changing your entire way of developing software and delivering it is not something you should do just because you felt like it. So the various people are going to push back on you and ask why. And this is good because they will force you to answer the questions yourself. Again, I can only really talk about our constraints, but hopefully I think most of these will match very well with the people who will push back on you. Users are fairly straightforward because they don't really care too much about the development model. They care about just getting what they wanted out of the system. Now, users here can be, in our case, it could be internal users who want the admin's interface updated, or there could be external users who we want to get software to faster. This is pretty straightforward. They just get their features and fixes faster, and more implicitly, there should be less breakages in the system. And it's going to be less, every Monday there's this nightmare of coming in and finding out something's broken. If you're constantly upgrading, it's much more of a smoother cadence, and hopefully problems are the exception and not the rule. Managers are interesting. Some love this, some hate it. Um, Most will love it when explained to them. I have this theory about Agile. I think one of the reasons why it was adopted so universally, so quickly, with complete buy-in from the whole organizations, apart from your occasional complete stick in the mud holdout, pretty much most people are like, yeah, this is great, we should do more of this, is because managers hate being kept in the dark. They hate this idea, the old waterfall model of, work for 6 months and then you just suddenly find out that the tests haven't been passing for 6 months or whatever. And then you've just blown your delivery schedule completely out of the water. If you're doing agile, you're doing weekly or bi-weekly sprints, you see results come in quickly, you get feedback faster, you can see on a nice chart what is being done and what is not. You can see if you're ahead or behind schedule, and that gets people higher up off their back and everyone's happy. So with this, again, I think managers are fairly easy to sell on this idea, as long as you assure them you're going to be careful about not breaking things, which of course we'll talk about. But ultimately, this is really an extension of Agile into the right up to the end user. Developers, again, it's this. One of the reasons developers like Agile is because it removed a lot of the death marches that went with product development. And again, we have this. In particular, it's interesting that you see this inside the Linux kernel development. They have this window comes out but every couple of months where Linux 12 says, okay, merge window is open, get your changes in. And a whole bunch of stuff is thrown at it, and towards the end of the merge window, there's this mad scramble, and just as it closes, they say, oh, please, can you just get this one thing in? Because they know it's going to take 3 months or something to get the next window to open, and they get another chance to get that in. It's the same with developers. If you have a once a week, or that's not too bad, you have once a month or once every 3 months release cycle, you've got to get that stuff in. And you've got to cut off on a Friday or a Thursday or whenever it is. You're going to be madly scrambling to get your changes in there, or someone's going to be breathing down your neck. But that means you're going to cut corners. Whereas if you say, well, I've decided this is going to take an extra half a day to polish this change, get the last few tests more robust, whatever. Then it takes half a day longer. Well, that means the change goes out half a day later. It doesn't really matter. If changes go out when they're ready, that's much easier and much less stressful. Now, the SysAdmins in particular, and ops are quite hard to sell on this because they often don't like the idea that developers are driving changes into their infrastructure. They are justifiably paranoid about that. However, there's one really powerful feature that sysadmins love about continuous delivery, continuous deployment, when it's done at its most extreme level, which is this. So you've got a weekly release schedule going on. Alice has decided to update the Ajax interface on the front end, on the web end. Bob has decided to modify the schema to the database slightly. Not very much, just a bit, just to optimize it slightly. And Charles has introduced a new PostgreSQL driver to update after a security issue. So 3 changes go out, and a database load spikes. Who caused it? The ops people are the ones who've got to work out what happened. What do we need to roll back? Can we roll forward? What's going on? Who's responsible for this? It's very, very tricky. You need to go pull it apart, put it into staging, find out what happens, maybe get a full dump of the database into staging, etc., etc., etc. However, if each one of those changes rolled out one at a time, and if you're being smart and your deployment system injects a notification into your monitoring systems that says, just a line in your monitoring systems that goes, release 3A went out here. And then after release 3A, the database spikes. You know exactly what just happened. And you know exactly what you've got to do about it, or at least you know who to talk to, and you know what your options are. This is a very, very powerful idea, and one of the most powerful ideas of this feature-based releasing of continuous deployment, of this very fine-grained incremental changes to your systems that and with good monitoring and good notification systems, suddenly a lot of things that were complicated before become very easy. So that's really the whys. Let's talk a bit about the hows. This is pretty much where most continuous deployment tends to stop. People say, oh, yeah, it's great, do it, off you go. And that's fair enough to a degree because every organization is different, every network is different. But there wasn't enough. We needed to do this, and we realized we were going to have to answer a bunch of questions about how to do this, and actually do a lot of research and find out what are the trade-offs between different ways of doing continuous deployment. And what I can do is now is tell you the answers that we came up with, and hopefully they will be of use to you. But first thing we'll do is we'll start with the development workflow. Obviously, continuous deployment implies a different development workflow. Really, it's not that different, because if you're doing what I would call modern software methodology, which is to say agile, short release cycles, feature-based, ticket-based systems, and a distributed version control system, or at least a modern version control system. But there's no major change there, but if you're not using that methodology, you're probably going to have quite a hard time. In fact, it's not going to really be possible. So the start is really common sense. This idea really started with Mozilla, and then developed further into, I think Ubuntu were quite big on this. Of everything is a bug. Everything is a feature request. Everything is something in a bug tracker. If Ubuntu famously had bug number one was Microsoft is the number one operating system in the world. They've actually closed that one because they don't think it's important anymore. It's quite true. Well, at least they have changed. Those other tracks are getting interesting. But the idea is that everything goes into the bug tracker. Mozilla actually had a bug for or an issue raised for have a massive party when Firefox 1 is released, things like that. So everything goes into bug tracker, and every individual piece of work goes in there, and you make it as fine-grained as possible. You break things into epics, into stories, into smaller and smaller subtasks until you've got something that is a piece of work that can be done, and then that has a unique ID, and that is used to track it end to end. That brings some massive benefits that I will show you towards the end of this talk. The way you use this is you work on a branch. This is where Subversion is not going to help you. It is not your friend. Subversion in particular does not really do branching and merging. I did maybe 2 major branches ever in Subversion, and both ended up in disaster. How many people here are using a distributed version control system? So I'm guessing about 2/3. How many people are still on Subversion or CVS or something like that? Oh yeah, sorry. Yeah. It is a massively different way of working, but the fact you can do branches and merges quickly and painlessly, and you've got a high degree of confidence in that your merges will not break something is a very, very powerful idea. But this is important. You isolate your work. You don't have, what you used to do in Subversion was you just do all your work up front, and then you kind of dump it into the system and hope it doesn't break anything. Then you do a code review. Whereas with a distributed version control system, or really more accurately, any version control system that does reliable branching and merging, then what you do is you break it off, you do multiple commits, you can maybe clean it up at the end afterwards if you so wish, depending on your policy regarding changing history, but you get it into a clean state where you've got a high degree of confidence that when you do the merge back to your main branch, it's not going to break anything. Part of that is because you will be running your tests against your branch. Every test that occurs on your main branch prior to release is being run on every commit that you make to your branch. Now, you need an automated system to do this, otherwise it's a pain in the ass. But it is pretty straightforward to do. You also need to throw a lot of hardware at this as well, but that is also cheaper than developer time, trust me. So every commit results in a build, results in a full test suite, and then you know when you get to that final point where you come to do a merge, you've got a high degree of confidence that you're not going to break anything. You can even do more complicated things, where there's one thing that Bamboo can do is you do your build, and after that build works, you then do a dummy merge or back onto the tree, and then you do the builds again, just to double check that actually it's not just a question that it works now, it'll work in the future as well when you come to do the merge. But this is quite important. Now, once you've got that into that state where you think the feature is complete and all the tests are passing and everything, then you want to do a merge. Now, we have a rule, and this is enforced at the server level, that no one can push to master. Master is sacrosanct. It can only be pushed via the server via a pull request. We use Bitbucket obviously, but there are I'm sure there are other tools out there to do that. Not important. But the pull request is, everyone hates code reviews, but pull requests are cool. I don't know what the difference is, but pull requests are kind of really code reviews. A chance for you to pull in other people. But you can also set other rules as well. So we, for instance, set a rule that you must have two reviewers acknowledge this. Sometimes you can set rules to say certain types of reviewer must be there, certain release managers must review everything, or the architect must review everything, or whatever. Or you can have a much more ad hoc one. We're a bit more lenient than that. We found people are generally pretty good when you trust them. But there's also rules like our Bamboo system, the build system, continuous integration system, actually talks back to the server and says the builds are passing, the builds are failing, and will actually block a merge if the builds are actually failing on a pull request. So this is about automation again. It's about putting as many guards in place. So, and we actually use pull requests as an education system as well. So if you've got a new developer on the team, we'll generally start pulling them into lots and lots of different pull requests. Even though they don't have much to add, they'll learn a lot as they do that. It's a way of sort of just piecemeal learning your way around the system. They see the discussions going on and what constitutes code quality on the team, etc. But once that's signed off, you can actually do the merge. We also have some rules around who can do the signing off in extreme cases, but I'll come back to that. So what happens is, when you do the merge, you press that merge button, it gets merged back onto the main branch. Now that every merge onto that main branch results in a full release. So you basically go through the entire release process every time a merge goes back onto the main branch. This is feature-based development. Every release has one change in it that could be tracked back to a branch. So you have this real traceability idea of, you've got a release, the release has a number, that number goes back to a merge, that merge goes back to a branch, that branch goes back to an original ticket, and so you know that particular release contains the contents of what is supposed to be achieved by this ticket over here. And this tracking idea goes all the way through. So this goes out to in our case, it goes out to the staging server. The staging server is where we introduce humans into the process. Obviously, we're doing pull requests, and obviously the developers are developing it. But at this point, we'd probably go back to the original customer, the person who raised the pull request. Maybe the BAs get involved. Maybe we get some QA people. If it's a critical one, we'll pull some more people in. We'll do a blitz and test it if it's possibly a critical one. Because this isn't iterated enough, in my opinion, that software is developed by humans for humans. The computers are just an aid to transferring data backwards and forwards between humans and other humans. Humans need to be involved in the process at some point. If you're not involving humans in the process, something's going wrong. Humans have better judgment on certain things. But the original point is, most things can be automated. So if you can automate as much as possible, do so, but ultimately humans do need to be involved in the process at some point. So we do this at the staging system. So we do full continuous deployment out onto the staging system. And then humans get involved and go, okay, is that sane? Only at that point do we promote up to production. And what goes out into production is exactly what was on staging. There's no separate build, there's no separate release. What goes out is exactly what was on the staging server. So we have a high degree of confidence that it's going to work in production. No weird changes are going to occur in between. Because these things builds can be environmental specific sometimes. It's not supposed to be, but they are. Everyone knows the old, it works on my computer, it doesn't work on the production thing story. So that's pretty much it. So that's how. Or it's how up to a point. Again, this is one of the areas where people just the story tends to sort of stop there. But this is where it gets really interesting for me. This is the way it actually got quite tricky. This is what I call the last mile. How do you get that stuff onto that staging server? And more importantly, how do you get onto a production server? How do you get onto a production server when you might have SOX compliance? You might have a dozen firewalls in between here and there and all sorts of things. How do you make sure you're not going to bring the system down? This is really where DevOps starts in its truest sense. I mean, DevOps has kind of lost its way a little bit, I think. It's some people say DevOps is just everything that I'm not doing, particularly developers. Developers or DevOps is a certification. It's a tool suite. It's continuous deployment or whatever. But DevOps is always supposed to be about cooperation between developers and operations. And this is really where this is absolutely true. Because to get your software onto these machines, you're going to have to talk to the sysadmins, and you're going to have to cooperate with them and come up with the best solution. And every organization is going to be different. I can't tell you how to do this. I can give you the guidelines and give you the process that we went through to discover the best tools for us. But ultimately, you haven't got buy-in from the sysadmins, it's all going to go wrong. You need to trust them, and they need to trust you. So this is what DevOps is supposed to be at its heart. So you should go and talk to your sysadmins and get them involved. There's normally two types of sysadmins. The ones who are like, yeah, let's do this, it'll be awesome. I'll get down and play with new toys. And then there's the other ones who are like, oh, I don't like the idea of that. But you need to win them over. Sometimes you need to make them think it's their idea. That's quite a good little trick to do. But it's very much a question of cooperation. It's a good time to go off and buy them a beer or something. And you're going to talk to the sysadmins, and eventually they're going to start discussing practical ways of getting code onto a server, possibly in AWS, possibly in your own secured bunker in Nevada mountains, at the mountains in Nevada. And they're probably going to come back into you and say, we should use Puppet, or we should use Chef. Probably because they have Puppet or Chef in production right now. This is the wrong answer. Do not do this. And this is very important. The why of it is very simple indeed. Puppet and Chef are about managing infrastructure, in particular about managing infrastructure at the server level. But your concerns are not at the server level. Your concerns are at the application and almost the cloud level, for once, to use the cloud term even further. But you've got cross-cutting concerns. You're not concerned about the server level. You're not even concerned about the application level in terms of J2EE or some blob of code running somewhere. You're concerned about databases and load balancers and the network in between them, and if there's more than one server, and what if those servers are on different data centers because you've got disaster recovery working. You're a cross-cutting concern. You can tell Puppet or Chef, I want this machine to look this way. How it gets there is entirely up to it. Telling Puppet or Chef, I need this amorphous mass of stuff to happen in a specific order is just simply not really practical. It's probably possible to do, if you were a Puppet or Chef master, to come up with some hack to do it, but it's not a good idea. So you're going to start looking at other tools. Tools that are designed more for orchestration, and these are what we call orchestration agents. So there's two types of orchestration out there. One's agent-based. Now, it's possible that you already have that out there. There are a bunch of them out there. SaltStack is quite hip. I haven't played with it yet. It's on my to-do list of toys. mCollective we did actually use for our full cloud offering for a while. Apparently, don't quote me on this, apparently from somebody who knows this stuff, it bleeds memory like you would not believe. Real problem there. The eventual solution was to just go restart it every half hour. So agent-based systems, by the way, should probably be clarified, are when you've got a piece of software that runs on each of your servers and it will perform actions on your behalf. This is a way of basically just doing things across your big cloud of various machines. Bamboo itself is actually an agent-based system. You could potentially use this. Funk, there's other ones out there. The point here is that if your sysadmins already have this in place, if they're already working with this sort of methodology, they're using mCollective or SaltStack or something to do all their changes to manage their infrastructure, use that. Absolutely perfect. Not a problem with that. However, if you're starting from scratch, if they don't have this kind of capability out there for mass modification of machines in a sequential way, then you're going to have problems because they're going to have to roll out all new infrastructure. And that's generally not something they're going to want to do, and it's something you probably don't want to do because it takes time. However, it's very likely they already have a massive parallel distributed modification architecture in place. That's called SSH. It's almost certainly already out there. It's secure. It has very fine-grained controls. You can put all sorts of interesting authorization systems on top of it. You can limit what a given user can do. You can create dummy users that only have very limited control. Accessing your infrastructure over SSH is probably the way you're going to want to go if you don't already have infrastructure in place. There are a number of tools out there that help you automate this, so that use this. So they work as orchestration systems, but they don't use their own agents. They just use SSH as a transport. You can just script this up with Bash if you really want to. There's Fabric, there's Capistrano's, Ansible. Ansible's quite hip, one that we use. Now, these are the tools I looked at. So what you need to do, you need to sit down with your sysadmins. Whoever, ideally you get someone who's going to be seconded onto the team, or you second onto their team, and you work together and you both have the job of getting this into place. Ideally, both teams together. And you need to go through what the current ecosystem is. Now, this doesn't take very long. We chose Ansible. And this was about a year and a half ago. The ecosystem may have changed. This is a rapidly changing world right now. So just make a table up. Just have a list of all of the options available to you. Just hunt around SaltStack and Ansible, Fabric, and whatever, and have a list of their properties and just weigh them up against each other. Take one or two, try them out, and learn. Do it with the sysadmins, because the sysadmins are going to be managing this system, and they're going to be writing some of these scripts. But as developers, you're also going to be writing these scripts. All of our deployment scripts are actually written by our developers, but then signed off by our operations team. So you need to be both working in this. This is DevOps in its purest sense. This is silos breaking down. But I can tell you what we did in the end. So this is what our solution for the last mile looks like. Bamboo does these releases. They're pushed out onto what's called the deployment environment. I'll talk about these briefly a bit later, but Bamboo has this concept of it understands the idea there are different environments that you may be interacting with. In particular, you might have a development environment for rush boxes, maybe even a per branch one. Then you'd have a staging environment and a production environment. And it understands that they exist and that you want different versions of software to be out on each one at different times. It also understands you have permissions around who can deploy to these different environments. So there's an agent that runs, and all that agent can do is talk to one of the production environments or the deployment environments, be it staging or development. And that can never be used for building, and never be used for talking to more than one environment. This is for security reasons. You do not want somebody running a build on an agent that has access to your production systems. So you need to separate out your deployment environments away from your build environments, because that's the problem with continuous deployment. It blurs the line between production and development, as it well should. But you don't want the power of the developers, who should have as much power as possible, to be bled into your production environments, where they should be much more locked down. In particular, if you have SOX compliance or PCI compliance issues, you're going to find that you want to have a very specific rule to say only certain people can actually access these production environments. Now, one of those people can be this agent, and that agent has a key, SSH key specific to it, that is used to access the production or the staging environments. So you need to isolate very much. So we use Bamboo to do this. You can use other systems. There are dedicated deployment, continuous deployment systems. Ours is much more a hybrid model in Bamboo. We'll find out what works for you. A lot of people use Jenkins for this. I will not badmouth one of our competitors. I don't mean it ironic or anything. It's just not my way. It's not the Atlassian way. A lot of smart people are using these tools. It does have one major issue. It does not have strong permissions. If you have a SOX or regulatory requirement about permissions, you want to be very careful about how can you lock down and say only certain people can perform releases into certain environments. In our case, our developers are never allowed to deploy into a production environment. This is a separation of duties concept that's required by some regulators. The person developing cannot be the person with access to a production system. So let's segue slightly here. Continuous deployment. Does that mean continuous downtime? The answer is it depends. That seems to be a bit of a theme on this particular conference. So one of the reasons why it took so long for us to get this out there was because we had to build a high availability system. We had to turn our monolithic system into something that could be could be upgraded without downtime. I'll go over this quite quickly. Ansible helps you with this. Ansible has the concept of rolling updates, and it has a concept of pre and post operations for each update. So what Ansible does for us, it contacts the load balancer, takes a server out of production, it then upgrades it and performs a bunch of tests on it to ensure that it is actually up and running correctly. It then will put it back into production and move on to the next server. It will stop if any server fails. You can specify certain clusters of servers can be upgraded. If you've got a massive cluster, you can upgrade them in batches. If a smaller one, you want to do them in series, or one at a time. But you need high availability for this. If you're releasing once a week, that's fine. If you're releasing several times a day, you're going to be talking about a lot of downtime. The last section is management. This is, again, not touched on very, very often here in talking about continuous deployment. You need to be able to trace this end to end. I'll talk briefly about the deployment environments. We've already covered them. Deployment environments inside Bamboo are, you can say there's different environments that have different roles out in your organization. Development, staging, production, but you want to move the releases between them. Each one of these really looks like a normal build plan. These are just a list of tasks that occur on release. It would have been built, the WAR in our case, the Java application we pass down as a binary blob, and then we just check out our Ansible scripts, which are in their Git repository, and we run our deployments. This is pretty straightforward, but it also manages release numbers for us as well. And what happens is you can actually see here is a particular example. HAL, by the way, is one part of our a microservice that deals with deploying to our cloud environment. You can actually see that there are 3 different environments: dev, sandbox, staging, and production, and each one of them has a different release on it. Now, this is good because Bamboo is tracking what is released where. Now, this gives us another really powerful concept, which is ticket-based management. This goes right back to the start. Remember I said track everything in a bug tracker, and that bug tracker will be your tracker ID will be your unique code throughout it. That's how it communicates backwards and forwards. So what you have here, this is the original ticket. As you can see, it's been 3 commits have occurred on this. So the bug tracker is talking to the stash environment, to our Git server, and it knows how many commits have occurred regarding this because it knows that there's a branch. It looks at the branch names and knows, oh, that's the branch related to this particular piece of work. And we know there's a pull request when it's been merged as well. So we know the status of development. We can actually look at our original ticket, and this becomes our dashboard into this. Now, obviously I'm talking about Jira and Bamboo and the rest here because this is particularly what I use. But there's no reason why you can't do this in other systems. Obviously, it goes without saying, from my point of view, it's easier to just do this. But then this also gives you a really, really powerful idea. If Bamboo knows there's the deployment environments and there's a ticket number, this pops up on each of our tickets. You can see that this particular piece of work, it's been merged and a deployment's occurred. It's been deployed out into the dev environment, it's been deployed out into the staging environment, but it has not yet been deployed out into the production environment. Now, this is really, really powerful idea as somebody who's got to get some work done without people screaming in your ears. Because if you give this to your customers, raise a ticket, and then we'll show you in that ticket each piece of work being done. Well, you can see the work's being done. You can see that the builds are failing. You can see that, oh, we fixed that. You can see it's been a pull request, it's been merged, it's gone out into staging. Staging, well, I can actually go and have a look at it now. Oh, it's gone out of production, it's all done. People leave you alone. People don't mind bad news. They don't mind. They understand that you're going to have good days and bad days, that development doesn't mean everything's perfect all the time. But they hate being kept in the dark. If you give them information, they'll leave you alone. This really, really powerful idea. So this is where this ticket-based management comes in. If you track your changes end to end right out into the production environment, then the user can see this. Now you can do this with Jira. You can build little dashboards. Dashing could do something like this. Would be quite nice. We used to have a dashing board that would show you. If you know dashing, it's like building little sort of wall boards that would show you what's out on each what version and which branches are open currently and which ones have been deployed out into different environments. So this is really powerful. You can actually give the information to your end users and carry on. The computers are tracking this for you. Just let them deal with the user at the front end, and you at least can point them at something and say, "There you go, work is occurring on this right now." So we're going to wrap up here. I just like to reiterate the main points here. You have to have a clear motivation for why you're doing this. Don't just do it because it's cool and it's fun. Although if you can sneak that in there somewhere, that's always fun. You have a branching workflow is absolutely key. You must keep your changes separate until they are ready, and then you must test those changes and have a high degree of confidence that when you merge them, they will be safe. But ultimately, it's about cooperation. This is DevOps in its purest form. It's about cooperation between people and tools and automating as much as possible. And then for the bits that you can't automate, it's cooperation. It's about talking to the people you need to talk to and about getting everyone on the same page and having the same goals, and ultimately having a lot more respect for each other. People, if you get them to work together, will generally have a lot more respect because everyone understands each other's constraints, the things that drive them on a day-to-day basis. So that's the end of my talk about a billion-dollar order system. The billion-dollar part seemed to work quite well. You guys remember to rate this session. I think we're going for more verbal questions. If you have any questions, I'm happy to take some now. And I'll be hanging around for the rest of the conference, so please feel free to grab me whenever you can. Cheers. So the question is, did we end up splitting them into smaller systems? Microservices is the hip new word at the moment. Yeah, no. So I go into my Australian accent when I get bad news. So if you want to actually hear about this, Atlassian's summit is in November, and somebody's giving a talk about what happened since I've left that team. About breaking up monolithic systems or working on monolithic systems. My personal experience is that it's harder than it looks. Everyone goes in and goes, "Oh yeah, so we'll just break it into this." And there's the customer service, and the database, like database service. In practice, it's a lot harder than it looks because there's so many cross-cutting implicit dependencies. What we started to do is all new systems were turned into new code, into new microservices. So it was more a question of, it wasn't so much that we split it up as we started adding in more and more smaller services around the outside and let the inside atrophy to the point where it became less and less critical. And it started becoming more like the logic engine in the center of the system, but things like emailing or the web front end or talking to our accounting systems are all split off into smaller systems. As much as possible, we're using REST where it's synchronous, and we're using queuing systems, in particular Hornet Queue for our where it's asynchronous. The reason being, Hornet Queue has strong transactional guarantees. Do not use ActiveMQ. It lies about its XA transaction support, by the way. Hope that answers the question. So the question is, could we use feature toggles instead of feature branches? Yes, but you have to have a high degree of confidence that the code that you're putting in there is not going to break something. Your feature toggles are not broken. So they absolutely can do that. According to I think Gartner a few years ago, that's the way to do it right now. Feature branches are out. Feature toggles are in. I'm slightly aware of feature toggles because it implies a big architectural change. Now, if you're doing microservices, if you've got very strong architecture that's very interface driven, then yes. But feature branches can generally work right now. Feature toggles mean re-architecting your entire system. Absolutely. So it depends a lot on, if you want to do things like A/B testing, feature toggles are absolutely the way to go because you're going to build that in anyway. If you know that you absolutely have to make this change, then yes. Yeah, it's a fair question. If you have the your system built in such a way that feature toggles are possible, that's definitely a way to go. It does incur some risk, though. in my opinion, but I don't, it's not very, it's not very strong opinion at this point. It's not something I've done a huge amount of. It's definitely a different approach if you're geared up that way, yes. Oh, that's an awesome question. We use Atlassian Jira, the best bug tracker in the world. Yeah, that's it basically. No, we use our own products. We dog food them. People, we generally we do dog food, so we do actually have our own problems. So we actually do continuous delivery on our own systems internally as well. So often, sometimes we will actually hit up bugs and so on because we are normally running on the bleeding edge. But it doesn't mean you get those quite cool features. So we do this integration. By the way, the big secret here: do not tell anyone in my company I told you this. It's all just REST APIs. There's no reason why, if you're using Jira but you're stuck on Jenkins, you can't make the same API calls that Bamboo would make to feed this information back. But I didn't tell you that. Okay. Thank you. Thank you very much.